All right, hello. Welcome back to another edition of Graph Guy. I'm Clark Richey, and I'm still the Graph Guy. Today, we have a very high chance in the forecast for dog cam, as they're already sniffing about my feet, and it's a nice sunny day here. So odds are high we'll get to see some dogs. But on the main event channel, as it were, we're going to pick up our conversation on graph modeling that we started last week. We're going to explore that in a couple of different new areas, picking up where we left off. And then, because at the very beginning, when I started this stream, I did promise that we would have other segments that were non-graph related and kind of just fun. We're going to have a special new segment at the end, surprise segment. No one knows what it is but me yet. So stay tuned and hopefully you like it. So let's switch over to our screen here. And hopefully this looks somewhat familiar. If you watched our episode last week, we started building out a sample model that represented retail. And so we have customers and email addresses and so on. And I'm not going to rehash all of this. You can simply go back and watch us on YouTube if you like. But I am going to focus today to start off with on a particular aspect of this model, and that is kind of this part of the chain right here. Customer to transaction to line item to product. And again, if you recall, we're talking about here, so when a customer makes a purchase, so think about going into the store yourself, any store really, and you buy a couple things and you get that receipt. That receipt has an ID on it. That's your transaction ID. If you need to make a return, they're going to link your products to that transaction ID on that receipt so you can get the appropriate refund when you bring back that item. And on that receipt, you see the things that you bought, how many of them you typically bought, or typically how many of them you bought, as well as what product you bought and the price. Those are the line items. So if I go in and I buy 2 cans of Mountain Dew, we would see a quantity 2, we'd see the Skew with the description for Mountain Dew and how much I paid for each of them. And of course, that Skew in the backend system ties to that product, which in this case is a Mountain Dew. If I bought other things, we'd have other line items on the receipt. So that's what we're talking about here. And these types of relationships for people who are new to graph modeling, particularly people whom, like most of us, have some kind of background, maybe very deeply, in a relational world, can be difficult to model properly. And so we're going to explore that today at the onset of this. And I'm going to start off with adding a new rule to our sort of graph modeling rules that we started creating last time. And this one, it's going to be very exciting. Wait for it. It is that nodes are not tables. Yep, I know what you're thinking. That is genius level stuff. That is like dolphins are not fish. Nodes are not tables. Duh, right? You're probably not very impressed and about to go find a new stream. But wait, there's a reason for that. When we come from, again, particular relational background, we're trained to think about things in a certain way. So let's look at an example of a very, very tiny amount of data that would probably represent a CSV file, for example, that would have this data, this transactional data, that we would want to load into our database. So if we look at that, and I'm going to kind of bring it up over here, and I made it nice and big, and we can see it alongside of our graph. I've only got one line of data, because that's all we need. But let's imagine our transactions are coming into us in roughly this format. We've got a column for the customer ID, a column for the transaction ID. We have the Skew. That's what's uniquely identifying that product, right? Just as customer ID is uniquely identifying our customer. Transaction ID uniquely identifying our transaction. Quantity and price, right? So very common format for a transactional file. as well as really any kind of data we get in often in CSV where we're linking a couple of things together, right? So this is a customer, this is a transaction, this is a Skew, and this is a product. So really we're linking three conceptual things together here with this data. In the relational world, we would, of course, to connect the customer, let's say the transaction, to the product, we would put the Skew of the product in the transaction, right? Because that's how we would know. We have a table that's a Skew in the transaction, because that's how we would know how to create that relationship, right? Because the relationships are tables. But here, right, in our graph database, we don't have that, right? What we have is me being unable to actually, there we go. We have me being unable to properly manipulate windows, but that's okay. So if we look again at transaction, it's only the transaction ID in there. We don't have this other, we don't have that Skew in there. So that confuses a lot of people. It's like, well, how am I going to know then for the transaction, like what customer is attached to, because the customer is not in the transaction, or what product or line item it's actually attached to. And we have to remember, this is where that rule comes in. Nodes are not tables, right? So when in this diagram of a model, right? So I'm just using a tool to create essentially a schema, a model for my graph database. This isn't representing actual instances of transactions and items and customers. This is the model for how that's going to work. If I think about this in terms of instances of that, I will have a customer with ID of 12, a transaction tied to a different a line item that has some information in it as well, and a product, right? Those things, so the customer is going to be connected to the transaction variable, not because the transaction has the customer ID, but because customer of ID of 12, we will create a relationship in the graph database that goes to the unique transaction whose ID here is 234252. And this is where that's important. If this was a table, right, the relationship goes from the customer table to the transaction table, and you have to figure out what row you're going to really, how do you tie those things together, and now you're materializing that, for example, that customer ID into this transaction table, so you know what customer made the transaction. But remember, in the graph database, nodes aren't tables. So if I have two customers, I have two separate nodes. If I have two transactions, I have two separate transactions. So I'm not linking a massive customer table that has rows in it to represent different customers. I have actually distinct customer nodes, which are separate data structures in the graph to a separate transaction. And because of that, I don't have to push that data into the things where it doesn't belong, right? I can find the customer with the correct ID. I can find or create the transaction with the correct ID. And then I simply can create them with this relationship. And now I can walk back, for example, from any product all the way through to all the customers who bought it by following these relationships. And again, that's all because nodes aren't tables. And as a side tidbit, this is also one of the reasons we can, in many, many scenarios, get significantly better performance in certain scenarios for graph databases than for relational databases. And again, your mileage are going to vary depending upon your graph database and your relational database and your use case. But typically, one of the problems seen in relational databases is if I'm doing a lot of data loading and I simultaneously want to query the database, that can cause problems. It can be hard to get. It can cause simply long waits for the queries. I've seen instances where essentially there's so much load happening in terms of inserting new data into the relational database that you effectively can't query it, or you're not getting up-to-date data because of the levels of sort of transactional isolation and things that have been set on the table. Why is that? Because again, if you think of these as tables, whenever I insert something into that transaction table, I have to lock the table, essentially. I'm doing a lock on it. And again, this is fairly high level. Yes, there are different locking mechanisms depending upon the database you're using. But you're still doing sort of a lock on that table. With a graph database, because every transaction in this example is a unique thing, unique data structure in the graph, I only have to lock the transaction I care about. I don't have to lock all of the transactions. I don't have to lock all of the customers. I'm only having to grab a lock on the things that I care about. And that allows for a great deal more flexibility to allow for queries to come in and be querying things at the same time data is being loaded. All again because nodes aren't tables. So hopefully this made some sense. Again, this is one of the hardest things. Resist that urge to duplicate the data. If you're looking at your model and you see, for example, that transaction and customer have some of the same data fields, or customer and phone number, because you're thinking in your mind, oh, how am I going to know whose phone number this is if I don't have the customer ID in it? You got to step back and remember that it's the relationship between the two specific instances that's going to define that for you. And you need to reevaluate your model and remove one of those duplicates. It's very rare to find an instance where you have to duplicate information across nodes in your model. So we'll capture that as well. Sort of as a corollary to this, be wary of nodes that have duplicated information. So again, for example, customer ID in customer and transaction. This is probably, I'm going to call it a relational holdover, right? Making that up on the spot. So again, it's a concept that I've probably used here because I'm thinking in a relational way. I'm thinking the tabular way. And again, that's normal. Don't feel bad about that. I've worked with a lot of different types of database systems. And every time I go from one to the other, it's an adjustment, whether you're going from relational to document, or document to graph, or graph to JSON. You've got to change your thinking a little bit, and that just takes some time. Awesome. So let's look at something else here. I'm gonna clear this one out and start with kind of a fresh slate here, and talk a little bit. This is kind of a classic example. You've probably seen examples of this on the web if you've done some searching on data modeling practices for graph. I want to explore what seems like a simple concept. I want to model people sending emails to other people, right? So let's just start off real simple, right? I start simply. So in my modeling tool, I have a person and I have an email, right? And in a person, I'm just going to give them a name. And then for email, we'll say the email is a subject, right? And we'll say it has a body. Super. So that makes sense, right? I'm going to capture sort of the high level view of what's an email. And I could just start off what seems really simple. I could say a person sends an email, right? And that email is sent to a person. And again, remember, this doesn't mean that Clark is always emailing Clark, although I won't say that's never happened. This is the model, right? So some person will send an email that'll go to a person. Could be the same person, is probably a different person. And at first, this looks like it might be fine. It's a nice, simple model. But some questions start to arise. So one of the questions you might ask is like, well, what if I want to know like when the email was sent? So when did I send the email? So where do I capture that? So I could, I suppose, put a property on the relationship sends email. So I could put a date sent here, but like then I kind of have to duplicate it over here, right? Because if I send an email uh, to my wife on a certain date, I would need to capture that twice. The other question becomes happening like, well, what if I send an email to a whole bunch of people too, and maybe some of them are copied versus just being on the main one of the main recipients of the email. This doesn't do such a great job of capturing that, right? Um, so what we're starting to see here is that what we thought was a very small problem of just like sending an email and capturing information about that, but really the act of sending an email is itself has data that is fairly complicated that we need to model. Most of the things we've talked about so far, we were modeling fairly concrete things. Even in our retail model, in addition to like customer and product, which are obviously concrete things, that transaction was fairly concrete. I can walk out of there with a receipt, which is often a physical thing. And so we were modeling mostly concrete things. But this idea of sending an email, that's much more of a nebulous or a more of an event type of a thing. So let's explore capturing more of an event detail in our model. Um, so let's just call that I don't know, call it I'm out of good names right now. We'll call this a sends email. And let's delete these relationships for the moment. And we'll say a person sends an sends an email. I'm not loving my names here, I'll be honest with you, but I'm stuck at the moment with that. So we're sending this email, and in here we want to capture things like date and time sent. We can capture, and then we can do other things here, like so send an email. And then the email, of course, to the body. And then the email, right, could like go back to a person, right? So email sent to person. Okay, so let's just kind of move some things around. So we could start, doing maybe a little bit more like this. So if I want to send an email, and maybe I send that email to a bunch of people, I could capture some metadata about when I sent the email, for example, the content of the email itself, then whom it's sent to. And this email could be sent to certainly multiple people. But what if I want to capture the entire conversation too, right? And I want to understand like that when I sent my wife an email, she then responded to me. So that we could use this structure, and this would be again her now sending an email back to me, but we've lost now the fact that email was sent in response to an original email, right? So we can restructure this a bit, and we can say, for example, that we could say that an email is a reply to, if I can spell reply right. So maybe when I send an email, it has a reply. It is in response to another email, right? So I sent an email to my wife My wife now sends another email. That email links back to my original email to say, hey, this is part of this thread. And now I can start to build this chain of emails. And of course, we can start to make some additional relationships here if we wanted to. We could be more granular and say that maybe the person was copied on an email, right? Versus being directed to the subject of the email, or of course, depending on what email client you're using, maybe I did a blind copy of the email to a person. And again, we're using different relationship types here. As a general rule, for the reasons we talked about in our last session, relating to readability, understandability, and often, but not necessarily, performance, again, depending upon your specific graph database implementation. And again, there's a lot of details we could go into here and keep fleshing this out. But the important concept here is that sometimes we have to, depending upon our use case and what we need to understand. So in this case, we wanted to understand details about the entire conversation, not just that a person sent an email to someone. If all we care about is that that fact exists, our original model of person sends an email to a person is probably more than sufficient. But if we really want to start to understand the thread of things and so forth, like this email sending event, I might want to know, for example, where was it sent from? So maybe originating IP. You might want to know, the relay information. You might want to know, a variety of metadata, again, about that event itself. A number of different ways to model that. But I think the key thing here that we walk away with is that when things start getting more complicated than just like a single property on one relationship, or maybe even two, that we really need, that we have a much richer event than is easily expressed just in the relationship. Don't be afraid to go ahead and make that event, make that action a node as well, right? That's a perfectly valid thing to do, and you can create some very, very rich models again with these types of relationships. So we'll capture that here. When modeling complex events, remember that the event itself can also be a node. Nodes aren't just physical objects. Cool. So you've got a handful of general modeling guidelines we've come up with. Again, there tends to be a bunch more. What we'll do in an upcoming show, not the next one, we're going to move on to some other topics beyond just graph modeling, is we'll probably take a particular domain and we'll dive much more deeply into that, perhaps with some actual data and things as well, so that we can look at some specific sort of gotchas and unusual situations that can come up. The one thing I will leave you with here on modeling that we have not talked about here is the concept of identity, right? So when I'm loading data into any database, whether it's a graph database, a relational database, document database, I need to have a way of differentiating one thing from another, whether it's a document from one document from another, or in this case, one person or email or transaction from another. That's a really important aspect of modeling that I've glossed over very intentionally here for a couple of reasons. One is that most databases, most graph databases in particular, since that's what we're dealing with here, do automatically give you IDs for things. So for example, if I'm using Neo4j, anytime I create a node, Neo4j will create an internal node ID that is available for me to use that'll identify unique things, and I can use that. And that may or may not be sufficient. Other databases may handle it a little differently, but there's, I would say pretty much always something internal to the database that very least will identify for you. But in a business case, that's typically not good enough, right? I need to use something of mine to identify that. So here, for example, we did talk about in our original retail use case here, we said, for example, that customer ID property is how we would want to identify customers. But that's not always the case. There isn't always enough information in a thing. It's not always a single property. It can get more complicated than that. And it is something you need to think about. We may have an episode where we talk about that, if we get some questions or whatever. Again, I'm glossing over it here because it gets very application or tooling dependent in terms of how you handle that. But again, do be aware, like I said, if I want to be to link these things together, I do have to have a good way of understanding what these things are in terms of how can I identify one transaction from another, one product from another, so that I can clearly link them in a way that matches my business rules. And that's really, really important. So we're coming up on our time, and I did promise you a new segment. So I've got a short segment here. I've even created a new little intro for it, and I'm calling this segment Cooking with Graph Guy. Hopefully I won't get sued for my image. We won't talk about that, but I love this guy. So Cooking with Graph Guy. In addition to doing graph, I like to cook. I like to garden as well. That could be a segment coming up, although it's fall now. And what I love to do most is combine those two and cook with things that I have grown. So what I'm going to show you right here to start off with, well, first we have a little puppy cam. So let's see, puppy cam. Oh, we're awfully close. We're zoomed in. We are zoomed in too close for the puppy. There we go. There's the big guy. All right. I wanted to show you this. All right, so these are, and I apologize, I'm zoomed in so close. My desk is a mess. But these are some pickled cherry tomatoes. Unfortunately, I did not grow these this year. A friend of mine grew them. I'm definitely going to grow them next year. But let's talk about that. These are really, really great. They're not super hot. They kind of explode in your mouth when you bite into them, which I love, and they're super, super easy to do. So essentially, all you need to do is you get a bunch of those red cherry peppers, wash them, dry them, cut the stems off them as much as possible. Pro tip here, you want to take a knife and you want to make sure you puncture the tip of them a bit, so that, not the tip of them rather, but put a puncture around. Let's go back to camera here. You kind of want to puncture them. I'm in the wrong camera. So many cameras. You kind of want to try to puncture the knife around the top of them. I try to hide it a little bit under the rim. This is a terrible image. I've got to do better. I am sorry. But so around the rim, that's going to let the brine that we're creating get into here. There we go. It's a little better. Get into the inside of the peppers in a much better way, because you want the brine inside those peppers. So you bite into them, you get that explosion of flavor. So first thing is you need to create your brine. I used about 2 cups of vinegar, white vinegar, and about 3/4 of a cup of water. The key thing is, again, more vinegar than water, and to that I added a little bit of sugar, about 2 tablespoons. The sugar really does a good job of sort of cutting that super vinegariness and adds a bit of sweetness that kind of offsets the spice of the cherry peppers. You're going to want to combine those 3 things, kind of get it to a nice boil, so that it's nice and warm. Once that's boiled and you've got the peppers prepared, You're going to put them in your canning jar. I used a warm water canning technique. I'm not going to go into warm water canning. Nothing special about, nothing different about the technique here, but I've got my cans prepped. I'm going to pack my my cherry peppers into the can, and then to that, I'm going to add a bunch of garlic. I like garlic a lot. I use 5 garlic cloves for about a pound of peppers. You can use more or less. I like a nice strong garlicky flavor. To that end, I also chop the garlic a bit so we get more surface area to infuse into our brine. You can keep them whole if you want. I also used about 3 bay leaves and about a teaspoon each of black peppercorns and mustard seed to give it, again, just a little bit more flavor. I've seen people add cilantro and some other spices. I wanted to keep this kind of simple at first. So once I've done that, again, I took some salt as well, about a teaspoon and a half, 2 teaspoons of salt. Poured the salt over the peppers, in addition to the spices we just talked about, and then I poured the brine over it, canned them, let them sit. These have been done for about a week and a half now. Really, really good and super easy. I'll try to get the recipe actually up for you online. But hopefully you enjoy that, and we'll talk again next week. Thank you for coming. This has been Graph Guy, and I'm Clark Richey, the Graph Guy. Thanks for joining.